The objective of this lesson is to see equivalent ratio patterns on a multiplication table. Let's look at a multiplication chart. There are many types of patterns, including ratios. We might see that we can skip count both in the rows and the columns. Let's look at an example. Jocelyn runs 2 miles every day. If we create a table using Jocelyn's miles run every day, we can add 2 miles to each day. This is the addend, while the skip counting pattern, 2, 4, 6, 8, etc., is the cumulative number, or the running total. If we compare this table to the multiplication chart, we can see that the multiples of 1 and the multiples of 2 are in the first 2 columns on the table of data and on the multiplication chart. Jocelyn's friend Haley runs 3 miles every day. If we add Haley's data to the table, we can see that her miles are increasing, just like Jocelyn's, but at a different rate. This rate can be modeled like a ratio of 2 to 3. Jocelyn's miles increase by 2 each time, and Haley's increase by 3 each time. If we add another iteration to the ratio, what does our model look like now? The ratio is now a ratio of 4 to 6. Look at the multiplication chart and find the ratio of Jocelyn's miles to the number of Haley's miles. The simplest form of each of these ratios can be found at the top of the columns. Let's look at another problem. Every day Max reads 4 chapters in a book and Gabe reads 7 chapters. How many chapters has Max read when Gabe has read 28? There are a number of ways to find the ratios. Using manipulatives, it might look like this. If a table of equivalent ratios is made, it may look like this. Using a multiplication table, we can find the equivalent ratios for various problems. The simplest form of this ratio is that Max reads 4 chapters for every 7 chapters Gabe reads. The objective of this lesson was to see the equivalent ratio patterns on a multiplication table. We met this objective by identifying a ratio on the multiplication chart and then finding the multiples on the columns or rows of the chart.